Hi everyone, welcome to this free tutorial video on Euclidean geometry, and this is part 1 out of a total of 10. This one focuses mainly on revision of all the geometry that you did from grade 8, 9 and some from grade 10. So now let's dive into it. So this is what you have. First of all, we spoke about a straight angle, right? That any perfect straight line, the sum of angles on a perfect straight line like this will always be 180 degrees. So at that point we have those two angles B1 and B2, when added sum up to 180 degrees. And the reason for this, whenever you use it, it's going to be angles on a straight line, abbreviated as angles on a straight line like that. Okay, and then we have angles around a point, which we sometimes call a revolution. This is a 360 degrees. It's when you start from this point, your initial point is this one, and then you come back to the very same point as your terminal point, right? So all those angles around that point will equate to what? To 360 degrees, and each time you use this, it's going to be a revolution, REV, or if you don't want to use that, then you can simply go for angles around a point, alright, which is PT like that. I would prefer this one because it's mainly shorter. Okay, then let's remember vertically opposite angles. That if we have two lines intersecting each other like that, the angles that are vertically opposite to each other are equal, which means this and that both equal, and also these two should be equal to each other, right? And lastly, my favorite, which is when you have two parallel lines, right? Remember that geometry is fun thing. It used to be something like that. Geometry is fun. So first of all, we speak of corresponding angles, ones that form either an F shape like this, or something like a T shape like that, or sometimes the F can even look like that, as long as when you take underneath the line you also take underneath, above the line you take above, below or underneath below, like that. As you can see here, you have those two parallel lines which I'm going to shade in red. This one, AB, is parallel to CD, right, and they are cut by a transversal, the transversal which is that line. But now let's look for the shape, either a T, the T shape, which is something like that, T or F. Then we have this, we have that. What do we have? We get the perfect, if we take above, we also take above. So that's why those two angles are equal to each other. And then we move on to the next one again, the other shape, which is what do we have? We have the U shape. Okay, we'll look at the U shape in a few. Let's look at the last one, which is the N or the Z shape, right, which is alternating angles. They are in alternating positions, so alternating angles. This one form a Z shape. The Z can be in two ways. It can be like that, a normal Z, or it can be stretched to be something like that, right? So by default, let's look at this. This angle right here is also going to be X based on vertically opposite angles. But now look at it, we are coming from that side, there's a line that goes down, there's another line that goes there, which means this angle right here should be equal to that angle right there. So you see, we had two options to find this angle. Either we use vertically opposite or we use alternating angles. And that's not the only one. We also have another angle again, which is what? Which is, let's try to find this one. If we consider that straight line right there, we are going to have this as 180 minus X, because X plus that angle should give us 180 degrees. Now look at it. Coming from that side, the Z stretches like that. Then off it goes to the last part, which is this. So we have that Z shape, which looks like a stretched Z, whereby this angle should be equal to that angle, which means even for this one we have 180 minus X, right? And then the last one, which is the U shape. Now those are co-interior angles. Co-interior angles are not equal to each other, but they are rather supplementary, which means if you have this angle right here, when you add it to that angle there, that's the U. You are coming from this side, you are going that side, and you go that side. So it forms a U shape that is something like that. These two angles are supposed to add up to 180 degrees. So we have X and whatever this angle is, right? As you can see, we can even calculate that. Considering this straight line, this will give us 180 minus X. So look at it. When we add the X plus the 180 minus X, what do you get? This cancels that. We have a 180 degrees. So co-interior angles are supplementary, they are not equal to each other, and we can have them on either side. Even this side we can still have co-interior angles, whereby this one and that one will give us 180 degrees. Okay, different types of triangle. One which is a scalene triangle. This one doesn't have any sides that are equal, right? No sides equal in length, right? And even the angles, if this is A, that has to be B, and that has to be C. All the angles are different in size. And then we have an isosceles triangle. You are going to use this a lot. It's very much important. Two sides are equal and base angles are equal. If we have this side as A, B, C, right? Before you conclude on the angles that are equal, you first need to comment about the sides. AB being equals to AC, right? And then this is given to us. Then you can therefore say that the angle B will be equals to the angle C, even though it's given, but the appropriate reason is angles opposite equal sides. All right, like that. And then we have an equilateral triangle whereby all sides are equal. All these sides are equal in length and all the angles are equals to 60 degrees. A right angle triangle, as the name is self-explanatory, there must be one angle which is equal to 90 degrees. And remember, you can only have one 90 degrees, right? You cannot have two 90-degree angle in one triangle, because when you sum them up in the end, they should give you 180. So if you assume that this is 90 degrees, then it means that would be 0 degrees, which wouldn't make sense. Okay, now let's move on. Sum of angles in a triangle. Angles in a triangle always add up to 180 degrees, which is something that we know up to so far. And then lastly, the exterior angle of a triangle. The exterior angle of a triangle is equal to the sum of the two interior opposites. So this angle right here is equal to this plus that. If you do not want to use that fact, first find this angle and use that straight line. So you can use the sum of angles in a triangle to find this one, then use the straight line. Okay, what we have right here, find all the missing angles. Look at A. If you look at A is this angle right here. But we do have the two interior angles there, right? Which is that 35 degrees and the 105 degrees. So by default, A is the exterior angle. So A should be equals to 105 degrees plus 35 degrees, which is the exterior angle of a what? Exterior angle of a triangle. And this will give us that A is equals to 140 degrees. Right, now we should focus on finding B. Now do not forget the parallel lines. We said parallel lines, let's mark them ST there, which is parallel to that line QR as given. Now the T shape to find B. If you look at B, B is above the parallel line in a corresponding position as A. So A and B are equal to each other. So A is equals to B, angle A is equals to angle B, and both of them are equals to 140 degrees. What did we say? F shape, which is corresponding angles, not just corresponding angles. Corresponding because the line ST is parallel to QR. You need to specify, right? And then let's move on. We need to find C. Now we can find C because look at that straight line right there. There's two angles on that straight line, B and C. And in fact, angle B plus angle C should give us 180 degrees, which is angles on a straight line. So it's angles on a straight line like that. So this will give us that angle C should be equals to 180 degrees minus angle B, which is 140 degrees, and that's none other than 40 degrees. So we do have C. After finding C, we need to find D. Look at C and D. C and D are vertically opposite to each other. So angle C is equals to angle D, and they are both equals to 40 degrees. Reason, these are vertically opposite angles, like that. Right. And then we should find E. Right, and if you look at E now, we are looking at this straight line giving us three angles. Now when you sum up those angles, being angle D, angle E plus the 105 degrees, this should give you 180 degrees, and these are angles on a straight line. All right, so at least you have a few there. You have D, which you calculated to be 40 degrees. You have E, which is unknown, and then the 105 degrees, which is equals to 180 degrees, and this should give you what? Angle E, which is equals to 180 minus that, which is 35 degrees. Angle E is 35 degrees. And then lastly, we need to find what? We need to find angle F. How will we find F? Let's see. And there's another way to find E. Look at that. There's that shape coming from this side, there, and there. So E is 35 degrees based on two reasons. Either angles on a straight line or alternating angles, right? Whatever between the two, whichever you spotted first. Right, and then let's look at F. F is equals to D. Why? Because F is above the parallel line, but there's another angle above the parallel line. Look at the T shape there. It goes like this. Right, so angle F, which is equals to angle E, and they are both equals to, we calculate, sorry, not E, angle F is equals to angle D. Angle F is equals to angle D, and that's equals to 40 degrees. And these are corresponding angles. They are in corresponding positions. Corresponding angles since ST is parallel to QR, like that. Okay, now moving on. Here's another one. Given that statement, you should find the angles from A to F. Let's see how far we can go with that. Let's remove this. And there we have it. In the figure below, FD is parallel to BC. Let's mark that. It is very much important to highlight what you are given so that it doesn't get confusing. Where's FD? FD is this line right here, which is said to be parallel to that line BC right there. Okay. And then from here, BAC is 52 degrees. There's the angle BAC. BAC is this angle right here. And BCA is 20 degrees. There's BCA right there, which is 20 degrees. Write down the size of each angle labeled A to F in that order. So they want you to calculate them starting with A. Where's A? Let's locate A first. A should be right here, as you can see. There, A is vertically opposite to that 20 degrees. So A is equals to 20 degrees, and those are vertically opposite angles. Right, and then what else? Where's B? B is right here. B is that angle there. How do we find B? Look at it. We have now two parallel lines that are cut by a transversal like that. And then if we take this side, the left of that parallel line, and this side, it must be the same. So if you look at it, you will see that B and 20 degrees are in corresponding positions. So angle B is equals to 20 degrees as well. Why is that? These are corresponding angles. They form what looks like an F. It goes like this, whereby this angle and that angle are equal to each other. So these are corresponding angles, and not just corresponding angles, because the line FD is parallel to the line BC, right? And then let's find C. Where's C? C is that angle right there. Remember now, if you look at C, it looks like it's not related to anything, but it is. If you add this angle right there and that, the exterior angle of a triangle is equal to the sum of the two interior opposite angles. So these two right here will give us C when summed up, right? If not, then you can calculate this angle first, which is angle AED, and then use angles on a straight line to find C. But the easiest way, angle C is equals to 52 degrees plus angle B, which is 20 degrees. And what's that? This is the exterior angle of a triangle, right? And then moving on, we have angle C, which is equals to 72 degrees. So let's find D. Where's D? D is that angle there. D is right here. How do we find D? Let's think about it for a second. We do not have E, we do not have F, right? And how are the parallel lines limited? Okay, maybe we can find D, but in order to find D, let's look at this. Here you have an isosceles triangle, this and that. So let's first conclude on that. You can see that EF will be equals to EB, right? And this is given to us. Then furthermore, if EF is equals to EB, then it means this angle right here should be equals to that, the base angles of an isosceles triangle. So angle D will be equals to the angle F, right? And these are angles opposite equal sides. So from here, let's find angle F, right? How will we find F? Easiest way to find F. Okay, F is not equals to B. We are not given parallel lines there. Okay, Let us first find E. This will not work for us. Let us first find angle E, okay? Because angle E, we can use that straight line on C, right? It's not even angle C, it's FEP. The angle FEP plus the angle C should give us 180 degrees. And these are what? These are angles on a straight line. So this gives us that angle FEP will be equals to 180 minus angle C, which is 72 degrees. So this should give us 108. So we get a 108 degrees for that angle E. But like we said, these two angles are equal to each other, which means then if we add the angle EFB, the one which we said is F, angle F plus angle D plus the angle which we just calculated, FEP, this should give us what? 180 degrees. And this is the sum of angles in what triangle? Sum of angles in triangle FEP, like that, right? So the angle F, remember angle F is equals to angle D, just like we concluded. No, we'll remove that. So after marking that EF is equals to EP, then we have that those two angles are equal to each other. Hence we can get rid of F and write it as D. So this becomes 2D. So angle D plus angle D plus FEP, which is 108, will give us 180 degrees. By default, 2D will be equals to that which is 72 degrees over 2, which is 36. 72 divided by 2, which is 36. So angle D is equals to 36 degrees. And once you have angle D, then you need to focus on finding angle E. How can we find angle E? Look at that triangle now. You always need to try and stretch your eyesight. You need to see beyond. So if you focus on this blue triangle right here, you will see that actually you have two known angles in that triangle. So focusing on triangle ABC, in triangle ABC we have what? 52 degrees plus the angle E plus 20 degrees, which will give us 180 degrees. And then by default angle E will be equals to what? 180 minus 72 degrees, which is 108, like that. So this is 108 degrees. And that's not even the last one. That's not even the only option. We could have used the two parallel lines, okay? We could have used corresponding angles even for that, because look at those two red lines, this angle underneath that parallel line and that angle right there. So even that could have worked out. Okay, now moving on, we need to find F. By default, F you will use a straight line because you now have D and F, DE. So angle F will be equals to 180 degrees minus 108 degrees for E, minus what? Minus 36 degrees for D. And this is what? This is angles on a straight line. Then you find whatever you find right there. Okay, so that's how you apply this. And then furthermore, you need to this is just basic stuff, practicing how to use the exterior angle of a triangle. Again, the sum of angles in a triangle will always equate to what? To 180 degrees. So here we are given three angles in terms of x. It's this one, it's that one, and that one. So in fact, if you add x plus the second one, which is 3x plus 10, plus the third one, which is x minus 20 degrees, should give you 180 degrees. And this is angles in a what? Angles in a triangle, right? And then from here, x plus 3x, so like terms, this plus that, which gives you 5x, plus 10 minus 20, which is 10 minus 20, which is minus 10, and that's equals to 180 degrees. In fact, 5x will be equals to 190 degrees. Divide by 5, which means x will be equals to 190 divided by 5, which is 38. X is equals to 38 degrees. And in fact, this angle right here will be 38. This will be 3 into 38 plus 10. Right, so 3 times 38 plus 10, which is equals to 124. Right, and this will be 38 minus 20, which is 18 degrees, like that. Again, remember what we said. On this one, you can either go straight for the exterior. The exterior angle of a triangle is equals to the sum of the two interior opposite angles, which means it's going to be x plus 48 degrees, which is equals to 2x. And this would be the exterior angle of a triangle. right, which will then take this to the other side. 48 is equals to 2x minus what? 2x minus x, which means x is equals to 48 degrees, like that. Is it? X plus 48 is equals to 2x. Yes. If not, then you could have calculated this angle right here first and then use this straight line, but otherwise the answer would be the same. How so? If you look at that FGE, sorry, angle FGE plus 48 plus x should give us what? Should give us 180 degrees, and this is the sum of angles in a triangle. So angles in a triangle, which will give us what? FGE, which will be equals to, transpose everything to the other side, so it's 180 minus 48, which will give you 132. So it's 132 minus x. So when you take this that side and that to the other side, now you are focusing on this straight line, whereby it's going to be the two angles. Now FGE when added to what? Angle FGE when added to 2x should give us 180 degrees, and these are angles on a straight line like that. So this will give us the following now: FGE, which is equals to 180 minus 2x. Sorry, no, we are not looking for that. We do have FGE. FGE we calculated, we got 132 minus x plus 2x, which is equals to 180 degrees. These are like terms. Negative x plus 2x is just x. So that's 180 minus 132. So what is 180 minus 132? Which is none other than 48. So it's up to you whether you shoot straight. If not, if you are unable to identify that, then you can take the long route. Right, now let us look into the Pythagoras theorem. Okay, the theorem of Pythagoras says that in any right angle triangle, the square on the hypotenuse equals to the sum of squares on the other two sides. You have to be able to identify the hypotenuse in any right angle triangle, and this is how you do it. Go to that right angle to the 90 degrees and draw a diagonal line, right, and extend that diagonal further. Whatever side it meets is always your hypotenuse. No matter how it's orientated, that's how you identify the hypotenuse. Even if I have a triangle that is something like that, whereby this is my 90 degrees, this is A, that's B, and that's C. To find the hypotenuse, I will just draw a diagonal there, then stretch it further. Whatever side it meets, that's the hypotenuse. In fact, in this triangle, the hypotenuse, which is B, the square on the hypotenuse, B squared, is equal to the sum of squares on the other two sides, A squared plus C squared. Always be careful of that. Now let's see. Which of the following triangles can you use the Pythagoras theorem with? This looks like there's no 90 degrees. This cannot be 90. That cannot be 90. This cannot be 90. So there's no 90 degree angle in any of those. So you can't use the Pythagoras theorem here. Same reason even for that. But for this one, yes, you can, because it's a right triangle. Pythagoras theorem only works on a right angle triangle, right? Given the triangles below, give the formula for the Pythagoras theorem in each. First of all, identify the hypotenuse. Draw that, then go for it. Which gives you what? Which gives you that your hypotenuse is A. So by default, then A squared should be equals to what? B squared plus C squared. The square on the hypotenuse equals to the sum of squares on the other two sides. Same thing, diagonal, extend further. This is your hypotenuse H. So by default, H squared will be equals to R squared plus L squared. Over and over again, diagonal side. Then your X is your hypotenuse, which means X squared will be equals to Y squared plus Z squared. Same thing, go for that. Hypotenuse, which is N, and this becomes N squared, which is equals to M squared plus P squared. Always remember this, so that when you are given something like that, you will know how to find the missing value. First of all, same old routine, stretch that and do what? Find your hypotenuse, which is A. So by default, A squared will be equals to what? Will be equals to the side B squared plus the other side, which is C squared, and this comes from the Pythagoras theorem. State your reason. So we don't have A squared, but we do have B. B is 5, so that's 5 squared plus C, which is 11 squared. So A squared, which is equals to what? Which is going to be 5 squared plus 11 squared, so that's 146. But remember, we're looking for A, so square root both sides. A is equals to, and you do not have to put the plus minus on the Pythagoras theorem because it's a distance. The hypotenuse is always a positive value, so it's just plus. So the square root of that, we should give you the square root of 146 or 12,08 centimeters, right? Okay, now let's look at the next one. The next one is the same as the first one. First, identify the hypotenuse, which is h. So h squared will be none other than what? The 12 squared plus 7 squared, like that. Third one, again, even for this one, you are still given the hypotenuse. This is important because in some instances you won't be given the hypotenuse. Say maybe, okay, in some instances you'll be given the hypotenuse and asked to look for the other side. Say you have 12 and then you have 6 this side. What is that side? X. First things first, do that so that you can see that, oh, that's my hypotenuse. And this becomes what? 12 squared, which is equals to that one, 6 squared plus x squared. So 12 squared, which is 144, 6 squared, which is 36, plus x squared. Transpose this, you have 144 minus 36, and this should give you an x squared. Right, so 144 minus 36, it should give you 108. So 108 is equals to x squared. Square root that, square root that. So the square root of 108, which should give us 6 root 2 x, which is equals to 6 square root 3, sorry, units, like that. Okay. Now let's move on. Congruency being the last one. Okay, congruency needs you to be very careful. Right, remember, if two triangles are congruent to each other, it simply means they are equal in length. Okay, when you place one triangle on top of the other, you won't be able to see the one underneath, just like that. So the first condition, which means you need to prove the sides. If one side on the first triangle is equal to one side on the other triangle, another side on the first triangle is equal to another side on the second triangle, and thirdly the same thing, then you can say the two triangles are congruent to each other. And the reason for this is side, 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 the easiest of them all, right? And then the second condition, which is side angle side. Now you need to be careful when it comes to this. It says two triangles are congruent if two sides and the included angle, which means if you have something that looks like this, whereby it's this side, it's that angle maybe, and that side, you cannot say these two triangles are congruent to each other, provided that they are orientated the same way, like this. This will not be necessarily be congruent to each other, despite the fact that you have two sides and one angle. The sides that you are proving with should include an angle in between. So since it's this side and that side, in order for you to prove, you need that angle. That's what this thing is saying. It's always side, angle, side, like that. Otherwise, these two may not necessarily be congruent because they don't follow that condition, despite the fact that it's two sides and one angle. And for this one, it's going to be side, angle, side, which sometimes you can write as SAS. And then thirdly, two triangles are congruent if two angles and one side of a triangle are equal. Okay, so this one doesn't have any special conditions. As long as you have two angles and a side, then you can use this, which is going to be angle, angle, side, or you can write it as angle, angle, side, like that. Furthermore, you have the last one, which is right angle hypotenuse side. You need to be careful when it comes to this. This one comes in this way. First of all, let's take two triangles. This triangle right here, whereby you are given this and you are given that. Okay. Right. So say you have the following two triangles. You have this as A, that's B, and that's C. That's D, E, and that's F. Right. So this is how you normally prove congruence. You start with in triangle ABC and the other triangle, which is DEF. Then whatever you do, everything that belongs to the first triangle should be on this side of the table, the other one on that side. As you can see now, AB is equals to ED, and this is given to us. You don't have to draw the table anyway, so let me remove that. AD, which is equals to that, this is given. And then secondly, we have AC, which is equals to DF. This is also given to us. And then lastly, look at the angle B. Angle B is equals to angle E, and this is still given, or they are both equals to 90 degrees. Then we can conclude now. When we conclude, this becomes therefore triangle ABC is then congruent to triangle what? DEF. Why are they congruent to each other? this is right angle hypotenuse side. Now this condition of right angle hypotenuse side should, first you need a right angle. You need to have a right angle. Do you have one? Yes, we did prove a right angle right there. We have this, we have that. So the right angle is proven. Secondly, you need to prove the hypotenuse. Remember the hypotenuse, draw a diagonal. Is the hypotenuse proven? Yes, it's AC and DF there. And then anything else, it could be any other side. Like that. Because this tends to trick people, especially if now you have a 90 degrees, but you have this side and that side. This will not be RHS because the hypotenuse is not proven. It's not marked in this case, but it will rather be side angle side. You have a side and angle in the side, despite the fact that the angle is a special angle, which is 90 degrees. Always be careful of that. Okay. And I think that marks the last part of what? Okay, not really, but we still have the midpoint theorem. Sorry, we have the midpoint theorem from grade 10, which states that a line drawn from one side, a line drawn from the midpoint of one side of a triangle parallel to this side will also cut that side into two equal parts like that. We'll cut AE and EC equal, which means it will go through the midpoint of AC. Hence it says that if AD is equals to DB, right, if you are given that this is equals to that and also that this is parallel to that, then you can conclude that the side AC will be equals to EC. And in fact, these two sides, the base sides, the inner base, that one will be the half of this long one. Hence you have DE, that one being the half of BC. Also the converse of it is true. What it's saying now is that if you just have a random line there which is DE, you can see there's nothing said about being parallel to BC. But that line goes through the midpoint of the first line and it also goes through the midpoint of the third side. So what can you conclude? You can conclude that this is parallel to that now. So first of all, let's just try to wrap up what we just said. You can have the following, right? Let's take these two triangles, right, and try if we have this right here and then we have that. Given the following A, B, C, D, E, this is what you are given, that this is parallel to that, and this is what? Given AB equals to BD, and that BC equals to BC is parallel to DE. What can you conclude? What can you conclude in that case? You can conclude the following, that AC will be equals to CE, like that. Also, look at the second one. If this is A, B, C, D, and E, right? If this is now, if you are given the following, that this is equals to that and this is equals to that, given that AB is equals to BD and also AC is equals to CE, what can you conclude in this case? You can conclude the following. You can conclude that BC will be parallel to DE, right? So here you are going to say this is the midpoint theorem for the original one, and this is the converse of the midpoint theorem, converse midpoint theorem, like that. And in both cases the side BC is going to be the half of DE. Okay, and this is where we can use that. Consider the diagram below and calculate the unknown X, Y, and Z values given reasons. So let us look into that. We have two triangles, one inscribed in another. So we have ADE and ABC. Look at ADE. ADE, which is that. And immediately on ADE we can calculate X. In fact, X plus 60 degrees plus 70 degrees should give us what? 180 degrees. And this is the sum of angles in a triangle, right? Or just angles in a triangle, which will then give us X plus this and that, which will give us 130 degrees is equals to 180 degrees. So X is equals to 150, not 150, X is equals to 50 degrees, like that. Okay, and once we have X, it means we have Y. But how? Let's look into it. We have a line that is drawn such that it was drawn exactly at the midpoint of the first side, but then it goes to the midpoint of the third side, like that, which means we have the converse of the midpoint theorem. In fact, here we can conclude that DE should be parallel to BC, and if DE is parallel to BC, what's the reason for that? This is the converse of the midpoint theorem. So converse midpoint theorem, right? So from here we have that x is equals to y, and both of them should be equals to 50 degrees. Why? Because now those are in corresponding positions. Remember, this is parallel to that, above the line, above the line. So these are corresponding angles. Why? Because the line DE is parallel to the line BC. And then moving on, they want us to find the length of Z. Remember, once we are able to prove the proportionality, the midpoint theorem, sorry, then we should have that the smaller side DE will be equals to the half of BC. But we do have the smaller side that, which is 2. So 2 is equals to half BC multiplied by 2 to get rid of this 2, which means BC will be equals to 4 centimeters. And there we go. And that's the end of it. Okay, now you need to practice this basic circle terminology. It's very much important. You need to know all these terms. So first of all, we define a circle as what? A circle is a set of points that are equidistant from a central point or from a focal point, which means they all share the same middle point, right? The distance from here to there should be the distance from here to there, from here to there, and then when you join all these points, these infinitely many points, they give you a circle, right? And then we have a radius which is said to be what? A line from center to any point on the circumference. So this can be a radius because it's the line from the center to the circumference which being the outer circle, like that. And in fact, all these radiuses, if I may put it like that, it's called the radii in plural form, are equal to each other if they are in the same circle. Like this radius right here will be equals to that radius there, it will be equals to that radius there, any other radius constructed, right? So all of them are equal to each other, and the plural for that is radii, or we call it radii, right? And then we have a diameter, which is a line that passes through the center. So a diameter is just two radiuses that are joined together, two radii joined together, but they form a straight line and pass through the center of a circle. So it is double the length of the radius. So diameter is equals to 2r, or rather the radius is equals to half the diameter, either one of the two. And then we have a chord, a line with endpoints on the circumference. So a chord is a line that starts on the circumference and goes to the circumference, not necessarily through the center, because once it goes through the center, it's now a diameter. It's a special chord. So this will be a chord. In fact, this will also be a chord, circumference to circumference. Okay. And then what else we have? We have a tangent. A tangent is a line that touches the circle at one point and one point only. It is always outside the circle. It's supposed to intersect it at a single point. Okay. And then we have what? A secant, which is that. A secant which is formed by what? This looks like a chord, but a chord which has been produced to go outside the circle. Remember, if we start here and we end there, this is a chord. But this one goes outside. And also have a segment which is that small region created by a chord. When that chord is drawn, this smaller area is called a segment. So that's what I need you to understand mostly: a radius, a diameter, a chord, a tangent. These are the most important things that we are going to use more in the next session. Okay, thank you.